Good evening, everyone. Okay, a quick check before we start the session. How many of you completed installation of Power BI? Okay, please can you respond in the chat window? Anyone joined only for today, just by any chance?
Yes, sir. This is Srinivas.
Okay, so we just discussed how to install Power BI. Not so complex one. That's the reason I'm asking. Just
Okay.
checking with you all. Okay, here we go. If you want to install Power BI desktop, just click on that start button, go to Microsoft Store, search for Power BI desktop. And the very first one you see is Power BI desktop, not the report builder or any other. So you just need to install this. Okay. In my case, it's been already installed. So I can directly open Power BI. Okay. So that's easy, but just I'm checking with you all. Anyone completed, the ones who attended yesterday's session, who all completed Power BI installation?
I have completed. Let me start over here.
Okay, I see that. A couple of charts coming. Okay. Okay. Fine then. Okay, so the other exercise what I gave yesterday is about identifying the keys, right? I see a few of you have shared a couple of things there. Customer code in the customers table. Okay. Student ID in the school student list. That's fine. Product ID in the products table. Okay, awesome. Okay, fine then. So let's talk about the same thing, about the keys and constraints in SQL. Before getting into Power BI, I would like you to just, understand these concepts, and then we'll proceed to Power BI concepts. So in the Power BI data modeling, SQL concepts are very much important. So let me just take you through what is primary key, what is foreign key, and other few things. So the ones who completed SQL sessions, you know these things, so you don't answer this. But let me ask this question to others who directly joined Power BI. Okay. Here we go. Take a look at this data, right? And you have employees table here. So I have a question. You may be coming from excellent SQL background, and most of you would have completed Excel sessions with us. So answer this, please. If I give you this data, and if I ask you a question about, okay, is it possible for you to, show me a summary, and that summary should be total salary paid by the department name. Is it possible to show? Total salary paid by the department name. Is it possible? Look at this table. And is it possible for us to create a report or a summary that shows total salary paid by the department name?
Yes, it is possible. We have department name and salary as well.
Okay, department name is there in the table and as well as salary, and we can easily create a report. Excellent. So one more thing, is it possible to create the maximum salary paid by the job? Maximum salary paid by the job. Okay, do you see the job column? Nothing but the designation column and salary column? Yes, no? All of you please respond.
Yes.
I mean, the ones who completed SQL also please respond.
Yes,
We see it, right?
it's there. Yes.
Yes, so both the columns are there. Perfect. And one last check. Can you find out the total number of employees basis on the gender?
Yes.
Yes.
Yeah, because we have the gender column. And as well as you just take the count of employee ID or employee name, you can get the each, gender wise, how many employees are there. Perfect. So, when you have data like this, it is easy for us to create the reports actually, right? Because everything is there in one place. So this is called denormalized data. Okay, everything is there in one place and easy to create the reports. But let me show you this example now. The data is not located in one place. If you observe the same data, I'm able to split this into, multiple tables like this, right? This is first table, second table, third table, fourth table. So 4 different tables. Okay. So using this table now, take a look at this. Using this table, is it possible for you to create a summary that shows the total salary paid by the department name? Is it possible? The selected data only. Answer this, please. Is it possible to create a report or a summary that shows the total salary paid by the department name? Is it possible?
No.
No. Okay. Why it's not possible?
Because we don't have department name here.
Correct. We don't have the department name in this table. But if I ask, create the summary that shows total salary paid by the department name, what is that you need to do?
Join.
Perfect. You need to perform a join there, right? So what is it you need to do? You need to look at the department ID here, and you need to get the department name from this table. So someone who is coming from SQL background, they call it join. Someone who is coming from Excel background, we call it
Pivot table. Sorry, we look up.
VLOOKUP. Perfect. So we do a VLOOKUP, right? Using the department ID as the common key, right? So that's what we understood, right? Understand one more very important thing here. In the real time, the data you usually don't see in the denormal form. You see the data in the normal form. Okay, so that's when these keys play a very, very, very important role. Okay, so let's try to understand the keys first, and then I'll come back to this model once again, whatever the employee table, department table and all. I want you to identify in this table, what should be our primary key. So let me tell you the definition of the primary key. A primary key is something that is unique and not null. Okay, so what is a primary key? A primary key is always unique and not null, right? So you tell me which one you think it's a primary key in this table, and probably the ones who completed SQL don't answer this. Yeah, which one you think, which column is qualified as a primary key column there? Answer this, please. Okay, so that's the reason I asked you guys to post a few things about the primary keys in the groups. Looks like you already did that. A few of you, please answer this. Which one is a primary key in this?
Both pay ID and employee ID both are not repeating. So either of the one can be primary key.
Okay, as both of them are not repeating, so either of the one can be primary key. Okay, but usually in a table, you find only one primary key, right? Sometimes you see the composite key where you need to combine a couple of columns together to create create the uniqueness there for that key. So that's a different story, but usually we see only one column as a primary key. So if I give you that option, I mean, you need to choose only one out of these two. Which one you choose? I mean, this is a question for all of you. What is that you think? Which one should be the primary key here?
Pay ID.
Yeah, pay
Yes,
ID.
it's by ID. Okay.
The payroll, it repeats.
Mm,
Employee ID may repeat.
yeah, that's absolutely right. So the moment we see something like employee ID and we think like, okay, employee ID is always a primary key, right? So can we call it a primary key in this table? No, always remember this. This is very, very important to understand what is a primary key. Of course, it says it is always unique and cannot be null. Yes, it is a primary key. And if you think about employee ID, you think like, okay, employee ID is always unique because your employee ID cannot be given to anyone else. Perfect. And your employee ID cannot be null. Yeah, that is also correct. But it all depends on which table you are looking at. And you are looking at which table? Employee payroll table. So employee payroll table, employee ID cannot be a primary key. You got a question, employee ID is always unique and cannot be null, right? And I think it is satisfying both the rules, but hold on, you're looking at that employee ID in the payroll table. So observe this. There is an employee who has an ID 1234 and who got paid in May 2023. And next month also the same person needs to be paid, right? And if you scroll down in June, yeah, same 1234 will be paid with the same employee ID. And if you see here, same. And not only that, just in case, yeah, of course, I've hidden something there. Yeah, there is a bonus paid to that employee, even that will be repeated. Understand, you cannot say employee ID as a primary key in this table. Why? Because you're looking at payroll table, the same employee ID to be repeated for multiple number of times. Right? But just in case, answer this please, just in case if your database developer marks employee ID as primary key in payroll table, you know what happens there? You know what will happen?
He can get paid only once.
Exactly. So this, for the entire career, okay, this particular employee who is working with that company will be paid only once. Why? Because the moment you mark something as a primary key, it won't allow you to repeat the same number again in this column. You got the point? Right? So that's how it is. Right. But what is a primary key in this table? So in this table, you need to consider pay ID as a primary key. Okay, why do we consider pay ID as a primary key? Because each and every pay that we do, that comes with one unique identification number and that cannot be blank. Right? So in this table, as we are looking at the payroll table, pay ID is a primary key. Okay, done. Similarly, if you go back to the employee ID column and there you get a question, okay, pay ID is a primary key, I understand, but how about this employee ID? What kind of a key do I need to call it? You need to call it as a foreign key. You got a confusion here, like what is this? You got some, confusion there. Like what is this foreign key? Why do I need to call it a foreign key, right? Primary key, I understand. In this table, each and every record that has one unique identification number and that cannot be blank like this, okay? Everything, every payment that we are making that is coming up with one unique identification number. So that I understand and I can mark this as a primary key. But when it comes to employee ID, why do we call this as a foreign key? Just because it is staying next to the primary key column, that's the reason we call it a foreign key? No. So then what is the reason that, why we call it a foreign key? Because understand the behavior of a foreign key or the explanation about a foreign key. A foreign key is a primary key of some other table. That's what it means. So that means if you're looking at a key, if it exists in some other table as a primary key, then you can call this as a foreign key. So that means in any other tables, when you go there and find out, it must be existing as a primary key. So let's go to the employee table. So in the employee table, if you observe, do you see any primary key there? Do you see any primary key there in the employee table?
Yes,
Yes. Yeah. What is that key?
employee ID.
ID.
Perfect. Employee ID is there. And yes, it is a primary key here. Why do we call this as a primary key in this table? Because you are looking at employee table. Each and every employee who joins our company gets one unique identification number and that cannot be duplicated. Right? I have a question here. So I am confidently saying, okay, employee ID is always marked as a primary key. That's okay. Each and every employee gets one unique identification number. Yeah, that sounds fine. But the question is this. What if the employee leaves the company? Can the same employee ID be given to anyone else?
No.
No.
Why no?
That's a unique number, right?
So anyways, once, let's say, one employee decided to leave the company, after leaving, the same employee ID can't that be given to anyone else?
No.
Okay, can you explain why it can't be assigned to anyone else?
Because generally we just soft delete them.
Okay, so let's say if we soft delete or just, it's as good as delete and it's no more there. So what will happen then? Is it okay? I mean, one thing is, let's say you delete it or you assign the same employee ID to anyone else. Isn't it okay? Or is it okay?
Not okay actually.
Yeah, it's not okay.
Why?
Because
Yeah.
because those details belongs to that customer might be duplicated. They will keep as a historical records of that employee, right?
Hmm.
So
Okay. Okay.
so that might create a duplication if in case they want to go through with all the
Okay.
employees' data.
Right. Okay. Okay. Right. Here we go. Once the employee leaves the company, you cannot assign that ID to anyone else. Remember. And the second one, what you need to remember is it cannot be deleted also. Only the employee status can be changed from active to inactive. There will be a status column we maintain, usually something like inactive. Okay. So that employee is no more with us. Okay. You get an idea that, why not deleting the employee record or why not assigning the same employee record to someone else? We cannot delete it. We cannot assign it to someone else. Again, the reason being, it's very simple. What if, let's say, Mahesh, quit this company and wants to join some other company and Mahesh submits all the documentation, right? Let's assume that this company, let's say this is ABC company. As soon as Mahesh left the company and that's 1, 2, 3, 4, is given to Suresh. And now Suresh is working in the same company using the same ID. Okay. When Mahesh joined, some other company and submits all the documentation, and definitely, that company tries to do this background verification, right? And when they write an email to this company saying, okay, 1234 employee ID, Mahesh worked from so and so time to so and so, so and so date to so and so. Like, please, can you confirm these details? And when that HR person looks at that 1234 ID, finds what? Suresh. And then HR person responds to the email saying that, okay, we don't find any Mahesh in our database because, with this employee ID, there is no one existing in our system. That's it. What will happen to Mahesh? You get the point now?
Yes.
Why an employee ID cannot be reassigned and cannot be deleted, because company's responsibility is to maintain the historical track of the all the employees. Because anytime, maybe after like 10-15 years also, a background check email may come. And that point, this company should be able to check the details of that employee. You get the point? Okay. So that's the reason you cannot delete it. You cannot reassign it. So in this case, employee table, employee ID is a primary key, is always unique and can't be null. And the same primary key, as it is acting as another key here. Which kind of a key is it? It's a foreign key. What is a foreign key? It's a primary key in some other table. Are we good now? All of you, please confirm if you understood this concept.
Yes.
Okay, so one final check. Take a look at this and tell me what is the primary key here.
Customer ID.
Okay, customer ID is the primary
No,
key.
no, sorry, account number.
Account number is a primary key. Yeah, check others also, please. Which
Account
one do you
number.
think? Oh, everyone says account number is the primary key. Okay, can you give me like an explanation why? Why do you think it's the primary key?
The table is bank accounts table, hence account number would be the
Okay.
primary key.
Yeah, because this is a bank accounts number, so the bank accounts numbers and all. So account number is the primary key. And look at this. Just if you look at this, you can easily figure this out. Is it duplicated?
Yes.
Yeah. This is also duplicated. So definitely customer ID and Aadhaar numbers cannot be duplicated, because I'll tell you one thing. One customer can have different types of accounts with the bank. Yes or no? In the same bank, you can have one savings bank account, home loan account, car loan account, credit card, and so many other types of accounts also, right? Overdraft account or any other kind of account, right? The customer ID remains same and you will be using the same customer ID to log in. But each and every account will have a different account number. Yes or no? You got the point? Right? So in this example, account number is a primary key, not the customer ID or the customer Aadhaar. Okay. So I hope all of you are okay with this. So with that, let me ask you a few questions. A simple example, student ID, is it a primary key?
Student ID in,
Yes, it's a primary key.
Okay. So it's a wrong answer if you say primary key or a
Based
foreign.
on the table.
yeah,
Based
Exactly.
based on the table, we can decide whether it is.
Exactly. That's absolutely correct. So student ID, if it is a primary key, both of them, like both, primary key, foreign key, both of them are incorrect answers only. Why incorrect answers? Because unless you know the table name, you cannot say whether it is a primary key or a foreign key. You get the point, right?
Okay.
Without knowing the table name, you cannot say whether it is a primary key or a foreign key. So student ID, is it a primary key? There is no right answer for this, okay? I'll tell you why. until or unless you know the table name. Here we go. If I say student ID in the student admissions table, then you tell me student ID in the student admissions table. Each and every student gets one unique identification number. So you tell me,
Primary.
what is it then?
Primary key.
It's a
Primary key.
It's a primary key. Excellent. Why? Because in the student admissions table, student ID is a primary key. Each and every student gets one unique identification number. But the same student ID in the examinations table,
Foreign key.
foreign key. Okay, why the student ID becomes a foreign key in the examinations table?
He appears multiple times.
Exactly. The same student needs to write the exams on multiple exams, right? Multiple times. So it is a foreign key there. What if student ID is marked as a primary key in the examinations table? What will happen?
He cannot write more than once.
Exactly. Join a college where the student ID is marked as primary key. I mean, on the lighter note, okay? So I'm just kidding, okay? It is not possible to mark a student ID as a primary key in the examinations table because the same student needs to take multiple, exams, right? Okay, so other thing, customer ID, is it a primary key?
Type of table is required.
Yeah, again, you need to ask the question. Okay, if you ask me, what is the right answer? If someone asks me customer ID, is it a primary key? The right answer is asking actually a question. You know, what is it? In which table? You should basically ask me in which table. Right? Okay, customer ID, is it a primary key? If someone asks, what is the right answer for this? Yeah. What is the correct answer for this? Customer ID, is it a primary key? What is the correct answer here?
In which table?
In which table? Correct. In which table? Okay, customer ID in the customers table. Each and every customer gets an ID, right? In the customers table. What do you think about this?
That's primary key.
It's a primary key. Excellent. The same customer ID in the transactions table.
Foreign key.
Foreign key. Yes. The same customer ID in the transactions table is a foreign key. Why? Because the same customer will visit the business for multiple number of times. Okay. Laptop serial number.
Table.
Which table? Perfect. Manufacturing table. Laptop manufacturing table.
Primary key.
Right. It's a primary key. But the same laptop serial number in the service center,
Foreign key.
it's a foreign key. Why? Because the same laptop can go for multiple number of times service. Okay. I usually give this example. I think with this, you all can easily understand. Vehicle registration number. What is that you think? Vehicle registration number.
In which tables?
Which table? Okay, RTA table, the one who issues the registration numbers and also. Which kind of key is it in the RTA table?
Primary
Primary key, excellent. In the traffic challans table?
foreign key.
Yeah,
Foreign key.
it can become a foreign key, right? Don't become a foreign key in the traffic challans table, okay? I hope you what I meant, right? I hope you got what I meant. Okay. All right then. So you got some idea, right? What is a primary key and a foreign key? Right. Now let me show you a couple of things in the data that we are going to use. Okay, take a look at this. You have 4 tables, you have the different keys there, right? Yeah. So take a look at this designations table first. So in this designations table, job ID is what kind of a key? I think looking at this, you should be able to answer. Which one is the,
Primary key.
okay, so we have a primary key. Okay, job ID is a primary key. Excellent. Why? Because each and every job is there only once. Yes, it is a primary key. But the same job ID in the employee table,
The
right?
foreign.
Exactly. We call this as a foreign key, right? You know, this actually helps us creating the relationships between the tables, and the same concept we discussed already in SQL. Right? I'm repeating the same topic once again here because once we start creating the relationships and models, we talk about the same thing. Right? So job ID in the employee table is a foreign key. The same job ID in the designation table is a primary key. So you know that, right? What is a foreign key? A foreign key is a primary key of some other table. Right. Okay. Similarly, department ID. Can you identify, a department ID here? What kind of a key in the employee table? The department ID is what kind of a key?
Foreign key.
Foreign key. Okay. Why do you want to call this as a foreign key? Because
It is a primary key of
Some other tables.
some other.
excellent. Yes, it's a primary key of some other table. You see that? Right. And similarly, you have gender. Gender in the employee table is a
Foreign key.
foreign key, and the same gender in the gender table is a
Primary key.
primary key. That's it. Right? Easy to understand, and we do this a lot in Excel also. We create VLOOKUP formulas, index match formulas, XLOOKUP formulas to fetch the data. In SQL, we do the joins. In Power BI, we create the relationships. Same concept, but with different names. But you may get another question here. Why do I really need to split the data into multiple tables? Why can't I have all the data in one place so that I can happily create the report? Yeah, that's absolutely right. If the data is there in one place, you can happily create the report, but this will lead to the data redundancy and inconsistency issues. So what is the data redundancy issue here? Data redundancy is nothing but the same values are repeated for multiple number of times. If you look at this, manager, 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 multiple times it is repeated. Instead of repeating the same word manager, what is that we are doing? We are simply assigning a key there. What is the key? Key one. One is what? One is manager. So I'll just write here one. Wherever I need manager, what is it I write? I simply write one there. One, one, one. Okay. So when we write one, what it represents? It represents manager, right? So why do we need to do that? One thing to reduce the redundancy, nothing but instead of repeating manager for multiple number of times, what is it we are repeating? Simply a key we are repeating. What is the advantage here? A simple thing. If you just imagine like this, if you take a pen and paper, you write one and you write manager. Which one takes more time to write?
Manager.
Manager. Why? Because it has so many alphabets to write. And which one consumes more ink to write?
Manager.
Manager, obviously, right? So you'll have to write MANAGER, but otherwise, if you just do a key there and if you write one, that is enough. So understand in order to save the space, right? The memory while storing the data, we go with these keys only. Okay, they help us to reduce the redundancy and inconsistency issues, right? Yes. So this process is called, instead of showing everything in one place, and if you split the tables into multiple small tables like this process is called data normalization. Okay, the technical definition may be sounding little different, but the overall concept sounds like this. If you have a data set that has all the information in one place, splitting the data into multiple tables and connecting them back using these keys is the process of the data normalization. Okay. Instead of storing everything in one place, what is it we do? We store this in multiple tables. Okay. When we split this data into multiple tables, we get two types of tables. Just two types of tables. In the Power BI data modeling also, once again, talk about the same, two types of tables. They are dimension tables and fact tables. The ones who completed SQL, you already have some idea what is a dimension table and what is a fact table, but let me explain this. Why? Because the same concept is used in Power BI as well. Okay, in the data modeling, we talk about this. I'll be showing you the schema designs. So there also you will understand what is a dimension table and what is a fact table. Okay, what is a dimension table? Very simple. After splitting the data, okay, you will get different types of tables, right? So basically two types of tables and multiple tables. So how to identify something is a dimension tables. Dimension table holds categorical data, something like qualitative data. Okay, categorical data or qualitative data, something that is not useful for calculations. And you get a question here, like what all tables are not useful for the calculations and which one actually holds here the categorical data. If I look at the departments table, I say that it's a dimension table, right? It's a dim table, dimension table, I call it. Okay, so why you call this as a dimension table? Why? Because this has a department related information, which is something like only for the categorization purpose I use it. And I cannot use it for any calculations. You get a question, I see the numbers, right? I can't use this column for the calculations. No. A simple example, can I do the sum of the department ID column and does it make sense? If I do the sum of the department ID, sum of department ID, and it is showing 150, this 150, does it make sense or not?
No.
No, it doesn't make sense any sense, right? Why? Because, doing the sum of the department ID, what is this number trying to tell us? Nothing actually. So understand? So this is not, a numerical data or something that is useful for the calculation. Of course, it is like an ID and which is in the number format, totally understandable. But using this, you can't do any calculations. So that's the reason I call this as a categorical table, and which is a dimension data. Coming to the designation table, this is also a dimension table. I call it a dim table. Why? Because this is also holding the categorical data and none of the columns are eligible for sum. Gender table is also a dimension table, right? This is also just some categorical data. I can show a dimension by the gender and here by the job, here by the department name I can show, right? So all three of them are dimension tables only. Then when it comes to the employee table, I call this as a fact table. Why do I call this as a fact table? Very simple. How to identify something is a fact table? It holds the numerical data. Then you get an idea like, even these are numerics only, right? These are numbers, these are numbers, these are numbers, and even these are also numbers. How do you say only employee table is a fact table? There is a reason. When I call something like a numerical data, it is not about the IDs, okay? A column should allow you to do the sum. If you can perform the sum of the column, if it makes sense, you call it fact table. Salary, sum of salary, does it make sense?
Yes.
Yes. Yeah, sum of salary, it definitely makes sense. Sum of commission amount, does it make sense?
Yes.
Yes.
Yes, definitely yes, right? But if you take some of gender ID or some of job ID or some of department ID or some of employee ID, they don't make any sense, right? Because they are just only for the identification purpose, right? So at least one column in a table, if it allows you to perform a sum, you can consider that as a fact table. I think you got some idea now. What is a fact table and a dimension table? And what is the process that helps us to get these fact tables and dimension tables? What is that process called?
Normalization.
Normalization.
Correct. Data normalization, right? Data normalization. And why do we prefer a normal form of the data? Why not a denormal data? Denormalized data?
Avoid the data redundancy and inconsistency issues.
Right. To reduce the data redundancy issues, we perform the data normalization. As a result, the table size will be significantly decreased. Right? I hope you understood this concept. Okay. So dimension tables and fact tables. So let me ask you a few questions about this data. And then I'll show you one more sample type also. Okay. Let's take a look at this. There is a data table. Okay. Just observe this carefully. The headers. Okay. And you identify whether it is a denormalized data or normalized data. Okay. You have order date, ship mode, customer ID, customer name, customer segment, customer country, customer city, REQ or something is there, customer state, postal code, region, product ID, category, subcategory, product name, and then finally sales quantity, discount, and profit. So what kind of data is this?
Denormalized.
Right. Why do you call this as denormalized data?
Because there's a lot of
All the information in single table.
Correct. Absolutely correct. Yeah. If you look at this customer ID, I just need the customer ID alone, right? I don't need the rest of the columns that belong to the customer. Actually, the same data is repeated, and this is like, increasing your model size or the table size, because the same records are repeated again and again, right? AA11096, if you have it, that is enough. But it is also repeating the same customer name, segment, and everything for the same customer. As a result, unnecessary columns are there. As a result, the table size will be more. Yes, this is denormalized data. Even if you look at the product related things also, I just need only the product ID. What is the point of having the category, subcategory, product name, and all other stuff? I don't need them. I just need only the ID. Using that ID, I can fetch the corresponding information, right? So this is denormalized data. The best thing with the denormalized data is, as everything is present in one table, it's easy for us to create reports. But let me show you this example. Take a look at this. Here you have row ID, order date, ship date, ship mode, customer ID, product ID, sales quantity, discount, profit. So what kind of data is this? Do you see all the customer related details like the customer name, customer region, state, country, all that? And similarly, product related details like product name, product subcategory, category, all that. Do you see all that information here in this table?
No.
No, we don't have that. Just in case, if you're looking for the customer related details, then you need to go to that customer ID. Let's say this is a customer ID I'll take for sample purpose. Okay. So this customer did these many transactions with us, 7 transactions. And who is that? Then yeah, I'll just go to the customers table. And here we go. This is the customer name and the other customer details. Then if I have this ID like this, I can fetch the customer name, customer region, and everything. You get the point? Right, I don't need to keep that information, the customer related information in this table. If needed, I can use a VLOOKUP and I can fetch that. But the same thing can be done in Power BI with the help of data modeling. And there we create the relationships. We don't want to store the data in one table. Okay, because we want to have the data model, right, to occupy very, very less space. Right, now you get the point. Okay, answer this please. Products table. Is it a fact table or a dimension table?
Dimension table.
It's a dimension table.
Yeah.
Perfect. In the products table, product ID is
Primary key.
primary key. The same product ID in the transactions table is
Foreign key.
excellent, foreign key, right? So I think with that, you understood what is a primary key, foreign key, and what is a fact table and dimension table. One final check. Customers table. What kind of a table is this?
It's a
Dimension table.
Dimension table. Okay. Products table
dimension,
Dimension table.
is a dimension table. Excellent. Transactions table
fact table,
It's a
is a
fact table.
fact table. Okay. How do you say that it's a fact table?
Say
Profit, sales,
Right.
discount.
Sales, quantity, and all these numerical fields are there, right? I can do the calculations. Correct. Yeah. People table.
Dimension table.
Okay.
the dimension table is.
You want to call this as a dimension table only?
it has some
Yeah, we
Target we have.
Hmm.
target
the
we
sum?
had, but we
Fact.
can sum it up because
Can we do the
It-
sum of the targets of all the people?
Can we consider this as a cost?
That's a target sales. Consider that as target sales.
yes, actually it's a fact table.
Yeah, I can do the sum of this target sales. So I can consider this as a fact table. Okay, fine then. Let me just show you one example or a sample data set. Someone who worked with W3 schools, you know this very well. So let me ask you a few questions. Let's come from here. Suppliers table. What kind of table is it? Is it a fact table or a dimension table?
Dimension table.
Dimension table, excellent. Shippers,
Dimension
dimension
table.
table.
right? I have the phone number, right? Can't I do the sum?
No.
No,
Yeah, not possible. Customers,
Dimension.
Dimension table.
Dimension table.
Excellent. Orders.
Dimension table.
Everyone says it's a dimension only?
Fact
Yes.
table.
It's
Okay.
dimension.
Okay.
Fact table.
It's a fact table. Okay. Why is it a fact table?
It has all the details of customer, employee.
Can you be a bit louder, please? Sorry.
Okay. No, it's a dimension table only.
You're saying, is it a fact table or a dimension table?
Dimension.
It's a dimension table. Okay. Yeah, that's correct. Because none of the columns are eligible for the sum there. Okay. Okay. Products table.
Fact table.
Fact table.
Okay. Let's hear it from others also. Others, please confirm what kind of a table is it?
Fact table.
Okay.
Dimension table, I feel,
It's
because
a dim table, sir.
it has a.
Why do you call this as a dimension table?
It has
There is no, but doesn't make sense of calculating all the prices.
So you mean to say, like, can't I take the sum of the prices?
No, we can take, but in this table, that doesn't make sense of calculating all the products sum.
Hmm. Others, what do you think? Is it a fact table or a dimension table?
It's
Fact
a dimension
table.
table.
It's fact table only.
Fact
Fact
table,
table.
because if
Hmm.
I am the customer and I'm buying, I have to make the sum of all the prices to pay the money. That's what I.
Okay, that's why you think it's a fact table. Okay, others, you give your explanation, please. Why do you think it's a dimension table?
We have price here. We can
Hmm.
sum up this price.
Okay. Can't we do the sum of the price?
We can do.
Yeah.
Okay, so
We
does it
can
make
get a
sense?
total
Huh.
price.
Hmm.
But
Uh,
what
the-
data, what data you are going to generate from this? It's a question mark again.
Right. If I do the sum of all these numbers and I get some number here, okay, is it not a useful number?
It's useful only, right?
If I perform the sum on this, is it not a useful number or not?
Will be a useful number for billing purpose.
Okay. So you understand which table are we looking at currently?
Product.
Products, right? Okay, perfect then. Let me ask you this, the same question in a little different way. Let's say consider this as a hotel menu card, okay? Okay, there is a menu card. And what is it we see in the menu card basically? You see the different products. Yes or no? Their
And
prices.
prices.
Yes. Okay, now you tell me how many of you actually tried doing the sum of that prices column when you visited a hotel or a restaurant, something? You tried doing a sum?
Yes.
No.
Oh, so you take the menu card and you open up the calculator, you sum up all the prices.
No.
Okay, I mean, doing the sum of that, all the products, let's say different 77 different, items are there in the menu card. Can't I do the sum of all the product prices there on the menu card?
We can do.
Okay, so does it make sense if I do that 77 items are offered in the menu and I do the sum of all of them? Does it make sense?
Doesn't.
No.
Understand? It's a dimension table. You got a question, price is there, right? Price kind of a thing can be summed up, right? Hold on. That can't be summed up. Why? Because on the menu card, if the restaurant is offering 77 different products in their menu, and if you take that menu card and if you do the sum of all those product prices, how does it help? You get a question, we place the order, right? And that's when we definitely need to, check the bill amount, you need to do the sum, right? Yes. Yes, we do that. But if you place an order, that means if you place an order, quantity comes into picture. If quantity comes and then quantity multiplies the product price, right? Let's say if you order these things, 2 items, okay? Then yes, whatever that 36 you get, Okay, that 36, 18 multiplies to 36 is the sale value. Yes, sale value is a measure, nothing but it's a fact. Okay, you can you can get this one for some purpose. You can use this one. But when you are looking at only the product prices, it doesn't allow you to do the sum. Remember the simple thing, if any column, yes, it may be a numerical column, something like a price, or a cost or something. If you cannot perform the sum of that, then you need to consider this as a dimension table only. Yes, it is a dimension table. It's not a fact. Then from this dimension table, if you want to turn this into a fact, you know what is needed? I told you already what is needed if you want to turn this into a fact.
Quantity.
Quantity is needed. Perfect. Quantity is a measure. Quantity helps us to get the sale value. You understood?
Yes.
Right. Now tell me, products table is a fact table or a dimension table?
Dimension table.
Dimension table. Perfect. Order details table. Take a look at this and tell me.
It's a fact table.
It's a fact table. Correct. Why? Because we have quantity and quantity. Can that be summed up?
Yes, sir. We can do sum of total quantity.
Correct. Yeah. If you take any real-time bill, observe that. Okay. Going forward, you need to understand and observe all these tiny things. Okay. Whenever you look at a bill, there is a rate column. Rate column cannot be summed up. You take any bill, recent bill. Okay. If you go for a shopping or something, if you buy, there is a product rate. Rate column cannot be summed up. But next to that, you will see the quantity column. Quantity column can be summed up. And next to that, price multiplies quantity is equal to sale value. Sale value will be summed up. But definitely not the rate column. Rate column is nothing but the price or the selling price. You understood? Right? With that, you have some idea, right? What is a dimension table and what is a fact table? Okay. Tell me this. Students admissions table that has a student ID, student name, student address, student mobile number, student father's name, mother's name.
Dimension table.
Dimension table. Perfect. Then you have one more table, student fee details table. There you have the student ID, student branch, okay? Student fee paid, student, hostel fee paid, something like that. You have the columns. Then
Fact
Fact
table.
table.
it's a fact table. Why? Because you can do the sum of those columns, right? You're getting the point. What is a fact table and what is a dimension table? Very, very important to understand. Why? Because once we get into the database side, we'll be talking about the fact tables and dimension tables only. Using these things, we create the models. Okay. So I hope I hope you understood what is a fact table and what is a dimension table. Everyone okay? Please confirm in the chat window or you can unmute yourself and if you're okay with this concept. Are we good so far? What is a fact table? What is a dimension table? Okay, perfect then. So let's proceed to this example. Right. You see one of the schema designs here, which is star schema design. Okay. So why do we call this as a star schema? There is a simple reason why we call this as a star schema because it looks like a star. Okay. So a star means not necessarily, it needs to look like a star, but something like this, it looks like a star, something that has, yeah, actually it's supposed to be connected like this. Okay. So what does it mean? A fact table that is surrounded by different dimension tables. And each and every dimension table can talk to or can connect to the fact table directly like this. Okay, so this is the schema design. And the one that you see in the center, it's a fact table. Okay, can you tell me what made this center table as qualified as a fact table?
Revenue
Units
units
sold.
Excellent. The revenue can be summed up, units can be summed up, right? These two, right? Actually making this as a fact table. And why the other things are dimension tables? Because you don't see none of them have any numerical data which can be summed up, right? So that's the reason we call them dimension tables only, all of them, right? And this design is called a star schema design. Okay, why do we call this as a star schema design? Because it looks like a star like this, right? It's basically a fact table is surrounded by multiple dimension tables. Okay, if you see a star, something like looks like this, right? So it doesn't necessarily, it doesn't need to look like this. Okay, definitely a 5-dimension tables. No, even if a fact table is connected to only one dimension table, is also considered as a star schema only. There may be other dimension tables also, depends on the requirement and the kind of relationships we create. But we usually see a good number of dimension tables are directly connected to the fact tables, so that you can consider this as a star schema design. Okay, like this. Right now, you understand what is a star schema? Very, very important, because in the data modeling fine-tuning concepts, we'll be talking about the star schema and snowflake schema. Yes, sometimes we go to the snowflake also, but most of the times we try to bring the data in like a star schema, right? So this is called a star schema. Then what is a snowflake schema? Snowflake schema that looks like this. Right. Why do you say this is a snowflake schema? Understand that a fact table that is surrounded by the dimension tables is called a star schema, but these dimension tables will have subdimensional tables like this. Okay. And yeah, how to identify something is a subdimensional table. See this, a dimension table has one more dimension table, and here one more dimension table. Here this dimension table has one more dimension table. Then you get a question like, why do we always prefer the data to be there in the star schema model? I'll explain with this example. Okay, so why don't we prefer a snowflake? I mean, it's not that you can completely avoid a snowflake. No, you can't avoid that, and certain things are there. You will still have to go with the snowflake, no other option. But we try to bring the data as close as possible, like this, like a star schema only, up to this level. But sometimes you can't avoid the other tables like this. Okay, we'll also talk about that in the data modeling. Okay, in detail discussion. Okay, so as long as your data looks like this, it's a star. Okay, it's a star. But if it goes beyond that and you have multiple other tables, then you need to consider that as a snowflake. Okay, so if you have the additional tables. So why don't we, prefer to have the snowflake? Understand one simple thing here. Snowflakes, as it has so many subdimensional tables, it will take a bit more time to process our requests. Why? How? Let's try to understand this. Your company wants to identify how many units we sold by the fuel type. Fuel type, we have like petrol, diesel, CNG, electric, hybrid, right? Different fuel type vehicles are there, and your business wants to understand, like by the fuel type, how many units we sold in the last month. Okay, in the last month, month comes from here, from the date dimension table. We talk about the date table concept also in the Power BI. Okay, date dimension, month will come. And what is the other thing? Can you identify where the fuel type is there, in which table?
products table.
Products
Variant.
table. Do we have this?
Va-
No,
Variant.
we don't have the fuel type here. It's there in
Other
Variant.
dimension table.
variant. Yes, here. So that means if your business wants to find out what is the total number of units sold in the last month, month comes from here directly. This is fine for your reporting. Units sold, anyways, it is here. You don't have any issue with that. But when it comes to the fuel type, this thing, how it needs to go. It needs to first of all go to the products table. From the products table, you need to go to the fuel type. You got the point? So the fuel type will have to come through this and finally this, and then including this dimension and this dimension, we try to show how many things we were able to sell in the last month, right? So that means if it has one more connection with one more subdimensional table, and that subdimensional table has one more subdimensional table, and if a field needs to come from this, okay? So that means from here to here it needs to come, and from here to here it needs to come, and then like this. So more number of tables, if you increase, then obviously the performance of the report will be hampered. And that is the reason what we try to do, whatever the subdimensional tables are there, if the size is very, very less, we try to merge that table into a main dimensional table. Okay, so in the data modeling concepts, I'll be talking about this, but see this, if you have multiple subdimensional tables, right, beyond your star, then you need to call it, what kind of a schema design is it? It's a snowflake. Right, now you understand. Okay, looking at this, I think you can easily answer this also. Which model runs faster? Snowflake
Star
design or star?
Star schema.
Star. Right, because the data is available in a few limited dimension tables directly connected to the fact tables. Right? Everyone okay with this concept?
Yes.
Yes.
Okay. Fine then. I hope you understood what is a dimension table, what is a fact table, and using these dimension tables and fact tables, how the models can be created. Okay. So you see the comparison, something that looks like this. You have a fact table surrounded by the dimension tables is a star schema, a fact table. You have a few dimension tables, and those dimension tables have the subdimensional tables. Okay, that's a snowflake. It's already there in the material package. Just go through that to understand how the data can be designed in a star schema or snowflake. Okay, so let me show you this. And you tell me what kind of a schema design you see here in this table.
It is just a fact table, sir. No.
Okay. Right, yeah, I can consider this as a, a star schema only, though there are no dimension tables. Okay, I don't want to confuse you now at this point, but let's take a look at this. Is it a star or is it
Star
a snowflake?
schema.
Okay, how do you know that it's a star schema?
We have fact table here,
Okay.
and it has dimension tables.
Oh, that's right. Yeah, it has dimension tables, and these dimension tables can be directly connected to your fact table. Okay. Fine then. So star schema, don't think it, definitely looks like a star. No, simple. A fact table connected to dimension tables, and you don't have any subdimensional tables here. Right? Okay. Fine then.
అదే నెంబర్ ఇచ్చారు కదా కాల్ చేయమని OLX లో మీ లొకేషన్ ఎక్కడ ఫ్రెండ్
Let me create one report. Okay. Probably you may want to try this. I hope all of you are ready with your Power BI desktop application. And I showed you the process already in yesterday's orientation session, how to install it. This is what you need to do. You need to go to Microsoft Store and search for Power BI desktop. And just click this, install it. Okay. And after that, you can open that. And remember, for the very first time when you open, it asks for the registration, cancel the registration. I'll tell you when to go for the registration. I want to create a simple report using this superstores data only. Okay. Let me just quickly create that. And anyways, I'll explain that later. I want to get the data from Excel workbook. Okay. The data is available here. Superstores data. Okay. I'm not going to explain what all I'm doing, but let me load these things. Anyways, I'll take you through all those steps once again. I'm working with the customers table, products table, transactions table. I need to do a little bit of transformation here. I'll explain this, okay? We'll anyways do this, okay? I'll explain one by one. And I want you to just pay attention and tell me what kind of a model it is. Okay. Okay. Tell me what kind of a data model is this? Is it, I mean, is it a star schema design or a snowflake?
Star schema.
Star schema.
Star schema. Perfect. How do you say that it's a star schema?
There is no sub-dimension tables here. We have fact table and dimension tables.
Okay,
Fact
perfect.
table is surrounded by dimension table.
Correct,
We
yeah.
have a
So,
fact table in the middle, and it's linked to the dimensions table.
correct, yeah. So how about this if I change the positions like this, okay? Now you tell me what kind of design is this?
Star.
Star schema only.
Same thing. There is a fact table linked with the dimension table.
Yeah. Don't get confused because of the arrangement of the tables, okay? Just because everything is falling, all the dimensions are looking like towards the right-hand side and the fact table is on the left-hand side. So don't think it is something like a snowflake or something. Still a dimension table, each dimension table directly connected to the fact table, it is still a star schema only. Okay, don't look at the positioning of the tables, okay? So positioning of the tables, it can be a many to one to many, it's just like all of them are same. I'll talk about all those things, but you understood, right? A fact table, if it is directly connected to dimension tables, you need to consider that as a star schema. In this example, how many dimension tables you see?
2 dimension
Two
tables.
dimension tables. How many fact tables we have?
One.
One fact.
One. What is that?
Transaction.
Right. How do you know transactions is a fact table here?
It has,
Because
It has
profit,
profit, quantity,
value,
sales.
profit.
Yeah, sales, profit, quantity, all these things are coming with this default summarization symbols. Okay, you can sum them up. Okay, sum them. Right. So it is a star schema design. Right. Perfect. Then you understood what is a dimension table, what is a fact table, how to identify them, right? Okay, perfect then. So let me take you through a few concepts of Power BI. Once again, in tomorrow session, we'll talk once again about the same thing because I give you some time to design that, whatever I did today, okay? Fine then. So why Power BI, right? All these concepts we are clear. SQL concepts like what is a primary key, what is a foreign key, what is a fact table, what is a dimension table, and what is a process that actually helps us to get these fact tables and dimension tables. And what is that process that we call? So that gives us these fact tables and dimension tables.
Data normalization.
Data normalization process, excellent. Yeah. So after doing all these things, what is that we are going to do? We load this data into Power BI. But why Power BI only? Why not Tableau or why not ClickSense? Right? Other tools also there. But Tableau or ClickSense, they're like little expensive. Right? So that's the reason most of the mid-scale, small-scale companies also able to, afford this Power BI and moving towards Power BI. And a lot of migration projects also coming up in Power BI, Tableau to Power BI migration or ClickSense to Power BI migration. Okay, here we go. Why we feel Power BI is easy to learn? The reason being it has a similar kind of an interface. If you see the layout of that user interface, it looks like very much similar to our Office products. Like you have the ribbon tabs, right? And you have the groups, Okay, I would like to tell you one interesting thing here. In Excel, there is a feature. If a value crosses certain condition, it should be highlighted. What is that feature called in Excel?
Conditional formatting.
Conditional formatting. Excellent. The same thing in click view. We call it visual cues. The same thing in SAP Crystal reports. It's highlighters, if I remember it right. In SAP Business Objects, it's alerters. Okay. And when it comes to Power BI, it's the same name, conditional formatting. You got the point. So whatever you learn in Excel, the same features with the same name, they are available. Okay. So most of the users, they find, learning Power BI is easy because all of us have some idea about Excel. All those features you can directly implement in Power BI. And writing the formulas also very much easy, very much similar. And it can integrate the data from any source. Okay, you just go here and find all of them there, like any source you write from Excel, CSV, JSON, PDF, Oracle, SQL Server, SAP HANA, Google BigQuery, whatnot. You name anything that is there. You can happily connect and you can read the data from there and start creating the reports. Highly interactive visuals. Okay, yesterday when we created one sample report, if you saw that, I was just able to click on any particular region or a category. I was able to filter the data on the visual itself. I'm able to filter the data, and all the visuals are connected by default. Nothing but if I select something on one visual, rest of the visuals will be automatically filtered. Once the reports are ready, then you can export them to PDF, PPT, Excel, all those standard, formats are available. And one more thing is that highly compressed data sets. The Power Query engine can compress the data sets, okay? Highly, it can compress so that the file size will be significantly reduced. Once we start working with the reports, we'll see the difference, okay? High quality visuals like map charts, field map charts, KPI cards, right? Responsive. They're like responsive in terms of their size and all. You just move here and there, they can respond to the changes automatically, and high quality visuals are possible. Just in case if you're looking for additional visuals that are not there in Power BI, something like, these are the standard visuals list. And if you're looking for some kind of an, a visual which is not present here in this list, you can actually get that from the app source. You can download very, very interesting visuals there, animated visuals, word clouds, right? Sunburst, infographics, right? Whisker box plot, water cup. You see that so many different types of charts, Sankey charts, infographic designer, right? Tachometers. You see that box and whisker, right? Heat maps, different kind of visuals you can download and you can use them. There are a few visuals which are uncertified, but most of them are Power BI certified like this. We'll talk about this, how to download them. It's like very easy. Okay. Custom visuals. That's what I'm talking about. You can freely download and you can use them. It's a cloud-based tool and you can access the data from anywhere using your PC, laptop, tab, anything. And every month enhancement emails will come, and their Power BI, that monthly email, it shows like what all have been enhanced and what are the new features that you can find. Like 4-5 years ago, or maybe like 6 years ago, these enhancements are like quite, high in number. Every month we used to get around a good 6 to 10 different kind of enhancements, and every now and then they used to change the interface also. Even the colors of the Power BI, whatever you see today, are like different from the ones initially, it was released. I'll show you that screenshot so that you will understand that the view completely, it has changed. It's a self-service tool. I'll also show you how you can simply drag and drop the things and create your own report. Important visuals can be pinned onto a dashboard. You need to understand there is a difference between a report and a dashboard. We usually what we use, in Excel also, if you create a report, we simply use a word like it's a dashboard, right? But here in Power BI, dashboard is different. A report is different. We'll talk about that. Okay. When we actually get into the Power BI service concepts, I'll talk about what is a dashboard and how to create. Yesterday, you remember something? Without knowing much about Power BI, anyone can create a report with the help of Q&A visual, right? You remember the Q&A, question and answer? What did I do there? You remember anyone tried creating it? I showed you one example. How did I create that Q&A visual yesterday? I did something.
Yes, sir. You have asked some questions to create.
Correct. I asked questions to Power BI, right? I just simply double clicked on the report canvas and I asked a question, okay, you please tell me what are my total sales or what are my total profit? Okay, show me the total sales by the state or show me the total sales by the customer segment. When I asked those questions, Power BI was able to create those automatic visuals for me. So something like using NLP, the natural language processing, it understands your question and it can create a visual, right? It created a bar chart and I said, no, I don't want the bar chart. I want a map chart, and it was able to change it, right? With simple English questions. So that is Q&A visuals possible, and automatically it can generate the data, generate the insights on the data. That's another thing. And a large community of Power BI developers help each other solving issues, right? So basically, there are Excel forums, right? To get the support. Similarly, we have Power BI. Yeah. So Power BI forums also available for the support purpose, and you can ask any kind of a question there, and there you get a response. Okay. So how to get the Power BI? I already showed you. So this is a few years ago, the interface used to look like this. Right now, the interface looks like this. Okay. Right. So we'll discuss in detail in our tomorrow session. We'll start from this, how to get the data. And there, once again, I need to talk about the SQL concepts. Using the keys, we'll create our first data model tomorrow. There are certain things that we need to follow before creating any kind of a report. There are certain steps to check the quality of the data, whether it is looking fine or do we have any other issues in the data. So I'll be talking about all those things. With that, we'll be done with the SQL concepts, and then we'll actually start developing the reports in Power BI. Right? Fine. Any questions so far? Everyone okay? Everyone okay to follow?
Hello, sir.
Okay.
Hello?
So, yes, please.
Yeah, in today's there is AI, no? Hello?
Yes, please. Yeah.
Artificial intelligence, no? There is a Power BI is okay, but in AI you can learn any more according to the Power BI.
Yes, absolutely right. We have a couple of sessions. I'll show you how you can integrate or how to use the ChatGPT or any other AI kind of a model, how to get the suggestions from there and how you can implement those things in Power BI. In the last couple of sessions, we'll be talking about. So we'll be first of all trying to learn all the concepts, then
Okay.
later how to take the help of AI.
Okay. Okay, sir.
Yes.
Thanks.
Yeah. Okay. Cool then. So thanks everyone for attending today, and I hope all of you are part of the permanent group and downloaded the material. Tomorrow, the material is very much needed to create our first report. So please be ready. Right? Any kind of assistance or something needed, you can yeah, feel free to post your message there in the group, and the front office team will take it up and will try to help you out. Okay. Great then. So thanks everyone. I'll see you.
Thank you.
Yeah, thank you. Bye.